This is Calculus, Topic 3, Homework Problems 22 and 41. The spot price on crude oil during the 2000 to 2005 can be approximated by the function here. P equals T times 5 times T plus 25, and that'll be dollars per barrel. Now, we can also approximate the crude oil production over the same period for the Saudis. And that will be, the production will be Q of T equals 0.082 T squared minus 0.22 T plus 8.2 million barrels a day. Okay, and we want to find the Saudis' daily oil revenue and also the rate of change in 2003. Now, T is between 0 and 5, so it means 2000. The year 2000 represents T equals 0, and 2001 represents T is 1, 2002 represents T is 2, and 2003 will represent that T is 3. So that's what we're looking for. T is 3. Now, let's go back and find the revenue. Revenue is made from price times demand. Well, our price function is here. It's the 5t plus 25. The demand function is here, which is 0.082 t squared minus 0.22t plus 8.2. Alright, so that's our revenue function. And since we want to know the revenue in 2003, we need to put 3 for all of these t's here. So let's put 3 here. 3 here. In fact, let's go with the calculator from here. 3, I want to store that into t, and t is found by alpha 4. Okay, so there it is, put in right now. And then we're going to put the equation in, which was parentheses 5 alpha t plus 25, close, open, 0.082 alpha t, let's square that, minus 0.22, then alpha t again, and plus 8.2. Let's close that. Alright, and we get 331.12. Okay. Alright, so that's our revenue. And that's also in millions. So that's in millions here. So we can also put this as 331,120,000. Okay. But they did say rounded in millions. So we can just have it as 331 million. Okay. Alright, next. We want to know what is the average, the rate of change in 2003. That's going to be instantaneous rate of change. So we need a derivative of the revenue function. So derivative will be the derivative of this function right here, which will be 5t plus 25 times this function here, which was 0.082 t squared minus 0.22 t plus 8.2, plus this function again, 5t plus 25 times this function, let's see, 8.2t squared minus 0.22t plus 8.2, and the derivative of that. Okay. Now, I'm going to work on the derivative of these two right here. The derivative of 5t plus 25 will be 5. So that'll be 5. The derivative here will be 2 times the 82, and that's going to end up being 0.164 t. And the derivative here will be 0.22. Okay, so that's it right there. Alright, so let's put all that into the calculator. Okay, so what we have is the quantity 5, and then open parenthesis. In fact, I can bring all that last equation up. So let's clear. Let's bring the last equation up. There we go. And I want to edit this down. I want to delete everything here but the 5. Okay. And then let's go make a plus sign here. And we're going to put the rest of it here, which is going to be parentheses 5 alpha t plus 25, close it, and then open it up, and we're going to put the derivative in there, which is 0.164 alpha t, let's see here, minus 0.22, and close that. Okay, and what we get is 52.27. So we get 52.27. Okay, and that's in millions per, let's see, what was the rate? I think that was, the time was in, looking for the time here. Oh, years. The time was in years. So that's millions of dollars per year. Okay. Or about $52 million a year. Alright, number 41. We want to take a derivative of this function here. Sorry about the little ink splot. But the derivative of this is, we'll use the rule that the derivative of b to the u will be the natural log of b times b to the u times u prime. So the derivative of this will be natural log of 7 times 7 to the x squared minus x, that's the bu, and then times x squared minus x, derivative. Now the derivative of x squared minus x will be 2x minus 1. So our final answer for the derivative will be 2x minus 1, I'll put up front, natural log of 7, and times 7x squared minus x.